and then
Get your slides going. So welcome to the May edition of ABCD-GIS. Today we are happy to have David Smiley with us. He's a graduate of computer science from Northeastern University, and currently is working for yourself,
pretty much,
and specializes in Apache Lucene and in Solr. And so with that, I'll turn it over to you.
Okay, great. It's good to be here. As you were talking about me, I brought this up, but let me start from the beginning again. So this talk is about Spatial and Lucene and Solr. I took two presentations I've given before. One of them at FOSS4G a year and a half ago now. It was an awesome conference, by the way. So that was to a geo crowd. That was not a search crowd. So I gave a presentation then about what is search, and hey, there's some geo stuff in search you might be interested. So I took some pieces of that together with as well as some deeper presentation to a search crowd about what is some new geo stuff coming in that's happening lately. So I kind of mushed those together, created one presentation that's kind of as a bit of both. So I start with a bit of telling you a bit about search technologies, because I think, especially when I'm at a non-search oriented conference, it's important to kind of get out like, hey, what is Lucene Solr all about? What is its core? What are the main things it's for? What's it do? Why would you use this on other systems? And then we'll get into some of the more geo stuff. I already had a little intro. It's about me. The book came out last year. I'm very much done writing books because it's such a ton of work. I don't recommend anybody write a book. Just kidding. Maybe one. Agenda. So again, search background, Spatial and Solr with a few how-tos, and towards the end there's some slides on some new stuff in Lucene. So search technology. This is primarily what Solr, Apache Solr is for, and within this the search space, these are the kinds of features that are really what search technologies do, that other things, other databases and whatnot tend to not do, or at least if they do some of these things, they don't particularly do it very well because that's not what they're focused on doing. So Apache Solr focuses on doing these things really well. Keyword search, and there's a lot to that. It's not just trivial, splitting on space and lowercasing. There's lots of nuance and lots of language-specific issues. Ranking results by relevancy. We see this when we go to Google. A lot of modern search interfaces these days have query completion, which is hugely useful. And it's important that work well and fast, and there's a lot to making that work well. And there's lots of different variations of these things, by the way. Not all query completion is created equal or the same. There are some that are fundamentally different. Basically spell check of your query, often displayed as "did you mean" on the screen. Highlighting snippets. You want to see a little snippet of your keyword search within the context of text that it matched in, for example. And faceting, which is not really, it goes great with search technology, but I wouldn't necessarily say it has to be a search thing. It just by coincidence, or maybe it's not coincidence, it just so happens that the major search platforms have faceting and databases conventionally don't. So I sort of bucket it together with search technology, even though there's no keyword search in faceting. And I'll have a whole slide about faceting if you don't know what that means, because it's particularly awesome if you've never, and you have seen it, even if you don't know what the word faceting is. And result clustering, that's, you don't see that too much, but sometimes when you have big unstructured text corpuses where you want some way to navigate it, you might, and some sort of interfaces like to bucket the results into different thematic buckets by certain keywords where certain documents are correlated by certain concepts. So that's called result clustering. And with search technology, there's lots of interesting operators beyond the kind of basics you might see in a relational database, say, like things like fuzzy matching. Search for this word, but it could be typoed and still find it anyway. And that's really sophisticated the way that works, and it's remarkably fast. Stuff like very textual stuff, like you search for a phrase, search for this near this other word within 20 words, or these kinds of things. This is what Solr does really well. Faceted navigation analytics. So I mentioned faceting before. It's important enough that it deserves its own slide because I'm partly, I think we're just proselytizing, but I wanted to share how important this is, I think, in navigation of large data sets. So we've all seen it. This is, I just went to some e-commerce site, Newegg. I don't even know if they're using Solr. It doesn't matter, whatever. It's the concept, whether or not whatever their chosen search backend is. I actually do think it's Solr, but anyway, notice that, so there's a keyword search in play, and then it shows you on the left, it basically aggregates certain fields and a count of how many it is. So in this case, there's a department, and it says that within department, there's internal hard drive. So you might imagine there's a field called hard drive, and then all drives, or whatchamacallit, hard drives, or the type of drive, SDD versus there's different types of drives and things. So basically it aggregates fields and provides a count. And it does this extremely fast and very purposeful. This is a direct feature of the platform. If you were bent on doing this with a relational database, you could. People have done that, but it's sort of like it's not like something that SQL expresses gracefully, and it doesn't necessarily perform. In fact, I really doubt it would perform nearly as well as Solr would do it, because Solr has 6, I think it has more actually, algorithms internally, and it chooses which one based on statistics and the type of the field, whether it's multi-valued or not, things like this, to choose the best path through, and even then you can tune it based on what you know about your data. Because this needs to come back super fast with your search, and it's super easy to do that. And it's useful, but not just for navigation, seen on the left. It's also useful to power dashboards. Same data, you just display it in a different way. You could do bar charts and pie charts with it, or you could use it as navigation. You might even use this as navigation. You actually click on these things when you go there. Obviously, Solr's not going to give you the UI. It's the data backend. It's giving you the counts and the values and the top X typically. Top X meaning the most frequent values in this field. But you can also sort it lexicographically if you need that as well. There's also some price range bucketing you can do. So it can aggregate certain range buckets of your choice on numeric data and give you counts for that as well. So it's not just discrete values. That's really important. I just wanted to mention that because I think that for a while before I got into search, I had my typical tool stack that I could solve most problems with, and that was my database, my whatever SQL of your variant of your choice, with my web front end of choice and my middle tier stack, and you could solve most things. But if your typical tools are a certain way, it can cause you to not see this in your vision of what something you're trying to build, because your tool chain doesn't make, although it can do a lot of things, it doesn't really do that well. And so I've seen people completely miss the obviousness of how effective this can be, even though we all see that interface day to day, and the apps we build, we don't necessarily have that, because it basically kind of requires us you use a search platform with it. You don't actually have to, but I mean, it makes this is like trivially easy with Solr in terms of getting the counts back. You really have to jump through hoops with a relational database to make that work. So search platforms, they're in the bigger picture of other of information retrieval. It's a database. It's not a SQL database, obviously, even though it recently added a SQL feature in Solr 6. I'd say it's in the NoSQL space of a search variety. If you could group them into different fundamentally types of databases, it's the search type, which can kind of look a little bit like a document-oriented database in terms of its data model, meaning you give it lots of so-called documents. It has a very limited structure of what those documents can be compared to, say, Mongo, which is extremely flexible. You can basically think of it as a bunch of field value pairs, where the values can be an array or multi-valued. You can do a lot with that. So beyond all that search stuff is all the other stuff you need as well. That's not necessarily search stuff, but it's the par for the course. If you're going to build a large data system, you need to do all these things, just like the databases do, you do as well. So you need a query language, you need some way to configure this thing, you need a way to kind of shard it out to more than one machine. Otherwise, you can only scale as much as your fastest machine can be. You need admin tools and whatnot. And you need the kind of basic, Boolean logic, this and or in your queries that are not, search oriented, but nonetheless, again, par for the course. And even though search platforms don't really excel at joins and grouping, it does support it, and that's very useful. I generally try and avoid it with the search platform unless it's clearly the only and right way to do it. When I first got into search, I often confused it with like almost being one and the same with a crawler, like web crawling, or like a website crawler. And those are really distinct things. There are web crawlers, and they feed their data into a search index, or maybe they just store it for machine learning later. So that's distinct from the search platform that gets its where you give it the documents. Where you get it from, whatever. it's not its domain. And my earlier misconceptions about search platforms was confused, like, oh, so if my data model is just a big blob of text, it can do that, but that's it? No. It's not just a big blob of text, even though if you think of web search, it's kind of like just what it is. But web search is just one sort of search platform use case where you've pretty much got one big search field other than the title and the URL. Again, it's name value pairs. You can put numbers in there, do range searches and stuff like that as well. So Apache Lucene is, I think, it's the most popular search library out there, period. I really don't think there's anything more popular than that. And most searches go through Lucene one way or another. I mean, I know that Google doesn't use it, but just about almost everything else does. And so Apache Lucene is just a library, though. It's just a framework. It's a very powerful framework and library, but it is just that. It is not a search server. There's no configuration file. You need to roll up your sleeves and write a bunch of code to work with it. And we're trying to make it easy. I'm not trying to say it's hard, but it's harder than using a search server that you don't need to write that much code necessarily to work with, at least certainly to play around with. So that's where Apache Solr comes in. And I'll mention Elasticsearch as well, because it's a competitor to Solr, and a lot of people use that as well. It basically adds everything else beyond Lucene that you need to make it to a server. And it does add some search stuff as well that Lucene doesn't have, or at least didn't have at the time that Solr added it. So Solr is basically is a server process where you interact with it over HTTP using various formats like XML or JSON. It's very flexible in that regard. You choose what you prefer. And so to illustrate the point of Lucene being just a library, there was a time when Lucene did not have faceting, and Solr did. So over time, Lucene has grown to have some of these capabilities as well. So in there, I'm trying to also say that Solr is not purely serverizing Lucene. It has a lot of stuff in there, a lot of search stuff too. Yeah. Spatial in Solr. This is basically a listing of the spatial capabilities within Solr. Effectively, you index. Well, most of the time, people's search requirements are indexing point data, but on occasion, some people want to index something else, like a polygon or circles or rectangles and such things. And you want to query by a shape as well. So if you're indexing point data, you might want everything within a certain radius of midpoint that represents the user or whatever your query is for whatever purpose. Once you start indexing non-point data, like polygons, then it raises the question of what sort of relationship do I want to search against with my query shape? Is it purely intersects, or is it just contains or within? You can make that distinction. Also, there's two kind of like, I call them kind of world models. There's a flat Euclidean 2D plane model, and which may or may not necessarily even be something on the Earth. Like people have used spatial capabilities in Solr to do interesting date-time stuff that was not possible with the other date-time stuff, simply because they were just mapping their data to numbers on a 2D plane. But by and large, people use it for stuff on the Earth. It might be projected data, it might be web Mercator, or they use the geodetic spherical model, which is basically a spherical representation of the Earth. There's a bit more flexibility in that now. I'll get into that. And the other common requirement is that once you start matching documents based on a spatial filter, you might then want to sort the results based on a distance of, if the document represents a point, then the point, the center of your query, for example. Or you might want a relevancy boost. What I mean by that, the word boost within search means influence the ranking through a formula. So this is one component of the ranking, but it's not the absolute sort. Anyway, you want the distance to get in there somehow. Heat maps, which is basically spatial grid faceting. I have more information on that. And it's flexible on the formats, GeoJSON and WKT. GeoJSON's new in Solr 6.1, which is not yet released, but it'll be out in like a month. And that's already committed, so it's on the slide. So big picture here with working with spatial in Solr is to understand some of these things. There are different spatial field types that vary in what they do, what features they support, and how they perform. There isn't one way that's best for everything. And if we gave you that one way, then someone else would make a way that was better in certain ways, and you want to use that. And so you end up to accept the fact that, again, there's no one best way to index everything. There might be ones that are commonly best or a good default, but there's still going to be a variety. Unfortunately, the syntax can vary, and that has to do with kind of the lineage of Solr and people working on it. And it'd be nice to, that could be cleaned up a little bit, but just wanted to point that out. Vary in performance, definitely. And sometimes it can really vary based on your query types too. For example, if you have tons of spatial data, but in the end, if you only ever end up matching like a handful of documents, then that can lead you strongly towards one direction versus another direction. So another thing I want to point out is there's the notion of shapes, aka geometry. So point, rectangle, circle, polygon, line strings, and paths, which are like buffered line strings. So you index shapes and you query by shape. And then typically it's the intersection, because typically it's a point and it's like a circle. That's most common. And for better and worse, it's just reality. Just FYI, there's spatial code in various layers of a stack here. There's spatial code in Solr. There's spatial code in Lucene. And as of Lucene 6, it's like in 3 different spots now. More people are working on it. More people have different ideas about where to put things, and we can't always agree. And we don't have a voting model, so it can make things awkward at times. And Spatial for J, which is another library under the location tech umbrella, as well as JTS, which is also under the location tech umbrella. So depending on what you're using, you use different things. It can make debugging challenging. I mean, I know where these things are, but for newcomers, admittedly, it's good to know that there's a whole stack here. So here's some basic how-tos. And again, there's multiple ways to do things, but so here we're configuring a field. This would go in Solr schema. And here I'm showing that literally using the XML syntax, you can opt to add fields and field types through an API call to Solr if you choose. So, but I'm showing here the XML format. There's a point, and you declare the type of the field. You can name it whatever you want. I just choosing location. Actually, I think I took this right out of the schema because that happens to be the very name and one of the basic types that Solr provides called LatLonType. And it has some options. In this case, it's subfield, suffix, whatever. You don't have to worry about that. And when you provide a document to Solr, if you use the JSON syntax, and there's other syntaxes too. You could use XML. You could use a CSV upload. There's flexibility there. But if you want to use the JSON syntax, then at the top level, you basically have name value pairs out of the field values in the document. So we have ID1, and point is the field. Notice the field name is point. There's the point field. And then we provide a string that is parsed by the LatLonType field, and it knows latitude, comma, longitude as a format. And that gets parsed. So it's pretty simple to index points. And this is one way. Well, I mentioned there are other ways. But depending on the field type you use, there are other possible syntaxes you can use. Although I would recommend exactly that syntax just for simple points. Polygons get a bit more interesting. So we can't use that field type. Remember that they have different features and performance characteristics. So the LatLonType is just for latitudes and longitudes. It's really pretty basic. This one I just call it RPT for short because it has a longer, more verbose name. There's actually 2 fields now that kind of bear that name, that RPT with geometry, and then there's the spatial recursive prefix tree that does not have geometry in the name. And the distinction is that this one actually puts the geometry, the actual serialized geometry, into the index, so that you can have an exact search ultimately, which is most likely what you want to do if you're indexing polygons or rectangles or circles. But if you just want point data, then you don't need to use this very specific field. You could use the other RPT one. Just want to point that out. So you see it's multi-valued. There's a reference guide page, has a whole bunch of info on some of these parameters. And so at index time, again, I use the same overall syntax of using a JSON document to Solr, ID1, the field name. And then we have in here, this is WKT syntax for the polygon. If you want to, you could use GeoJSON. In fact, I have an example of that later. Polygons, OK. Search / filter, same kind of thing. It's basically matching documents based on a query shape that overlaps with the index shapes. So some of this assumes some Solr knowledge here, obviously. So FQ is a parameter to Solr. FQ is a filter query. I could have used Q if I wanted to, whatever. It starts with, Solr has some flexibility in how you start a query. And in some cases, you can start with that tilde exclamation to call out a particular so-called query parser. And here we're using a spatial query parser called GeoFilt. And that's kind of that's been the default one in Solr for years now. So I recommend people use it because as long as you're just doing a point radius query, then just go with the typical approach. So you reference the field and you reference the point in a separate parameter, and you'll match all documents where there's that point and that radius with that's in kilometers where there's a match to point data. That will work on, and that syntax works across the board on the various field types in Solr for spatial. If you have a bounding box that you want to say, GeoFilt is a point radius query. It's a circle, basically. The syntax right here is a range query, latitude, longitude, bounding box. Get the idea by looking at it. And then there's a more complex example is where you have a polygon. And so honestly, I don't love this syntax. There's a issue in Jira about improving it to make one that's both more spatially recognizable to people in the geo area as well as a more Solr friendly one. Like st_intersects, st_contains, those kinds of naming conventions you see in the spatial extensions to SQL. So doing a similar kind of thing, but this is what we've got. And basically starts with the predicate, and then the shape goes within the outer parentheses. So we have a polygon here. This is just a simple triangle. And that's just an extra parameter that you could set, or don't set it if you don't care. And there's other predicates available.
What is that, error percentage or what?
That's a complicated subject. So up until the last, about 1 year ago, I finally added the RPT with geometry field I referenced in the previous slide. And that gives you exact, that's what most people get. So if you use PostGIS or something like that. And it's what most people want, especially for non-point data. So you're indexing polygons and you want to take an index polygon, you got a query polygon or a query point or whatever, and you want to, is there a match? And so that's a little bit historical. So you can, if you use the RPT with geometry, I wouldn't have even had that on a slide. In fact, I keep the slide simpler. I should have removed it so to avoid this question. Before that existed, though, the geometry was not in the index. It represented everything completely by a grid. So for point data, this is fine because you can represent a point just by going one more grid cell level down, and it's very scalable. There's no real issue. It's not a problem. But the moment you want to represent an indexed polygon as grid squares, you're fundamentally you're quantizing. You're basically take a piece of graph paper and draw something and box it all out, and there's a certain precision there, and this kind of controlled that. So if you're putting non-point data into Solr, you would use RPT with geometry. You wouldn't even specify that because it defaults to that, and you would get exact matches because it internally has a two-phase approach. It uses a grid, and then once the grid is able to tell it which matches are fully confident versus those that are not so sure, and it double checks the not so sure ones. So you get an exact result. There's a lot of internal details that Solr kind of exposes that gives you knobs to tune that with many other systems that I've seen are more of a black box. Easy to use, but there's no, fewer knobs, right?
So does this do the spherical geometry behind the scene? Because you're using latitude and longitude, and then
So-
you're talking about Cartesian coordinates.
Okay, so if you use a latitude longitude box that's sort of like a almost doesn't count. It's like a not applicable because it's by definition like a rectangle. But if it's a circle, point radius, then that is on the surface of a sphere. It does use the Haver sign. Actually, it's configurable which algorithm you want to use, but it's on the surface of a sphere, a point and a radius. And you can even choose the Vincenti algorithm if you want, which will get you ellipsoidal. And that's, so there is on the surface of a sphere, and there's Euclidean. And that's, at the time, the syntax is the same here. At the time you declare the field, you declare either geo equals true or false. And perhaps that's not well named. It should be, spherical or flat. And if you use spherical, then your point radius queries are on the surface of a sphere. Now, the lie there, though, is that polygons are always in 2D anyway. So there's just polygons operate because the polygon implementation we have, and this is actually, that's a good question because there's I'm going to mention Geo3D very soon, and Geo3D is on the surface of a sphere, but that's new, and there's a little bit of manual work in hooking that up to Solr because it's not automatic yet. So there is the potential for that capability, and depending on how much you roll up your sleeves or whether you want to do things at the Lucene layer or Solr layer, you can get surface of sphere polygons, which is pretty awesome, by the way, because you just don't see that much. It's like very, very hard to find that, especially in open source. Like I've seen one library that did it, and it's not for the faint of heart, and it didn't even quite do things exactly how I wanted it to work with Solr and Lucene. So anyway, so that's a good point, a good gotcha. Polygons operate in 2D no matter what you set on the field type. That will not eventually be so once I hook up Geo3D properly, but that is the case today. And it is the case today as well that you need to add the JTS library to Spatial for J, which is what implements the polygons. And JTS is fundamentally 2D, Euclidean. GeoJSON. So this is new as of 6.1, and there's some JSON examples of a point, and I use the point over the slide just because it's concise. I can fit it on the slide without a more verbose polygon. That's the only reason why. And I'm sort of showing 3 places you can possibly use this format distinction. You can supply your data as GeoJSON. You can search, so your query shape is GeoJSON. Not very typical to use a point as your query shape. Normally it's like a circle or something like that, not a point, but it could happen. And again, it's for brevity on the slide. And you can ask for it back. And the purpose is to make it a little easier to integrate with, say, Leaflet or something like that on the browser side, but you want to more easily adapt it to a known format. And this is sort of an amalgamation of a combination of GeoJSON with Solr's response too, because you have faceting, you've got other kind of data that isn't strictly GeoJSON that you want to get back. So the normal document fields go here, and you've got things like numFound and start that are more Solr-y. And I think faceting would show up down there too. Okay, distance sorting and boosting. I'll glance over this briefly because I want to move on for time. Indexing rectangles, you don't have to use bounding box field. You could put it in an RPT. You could use RPT with geometry, and it will work. But certain fields, again, have certain benefits that are unique to it. Bounding box field has some pretty cool overlap relevancy. So you might want to sort your results by the relative overlap between your screen window and the indexed one. Because if you just barely clip some massive rectangle of some state or whatever on your screen, that's arguably not that relevant compared to something smack dab in the middle that's covering most of your screen. That's largely the purpose of why this field exists. And you can be very, very precise on some of the predicates. You can do equals, I think. I think that's the only one that does that. Yeah, and that's an example of sorting by overlap ratio. It's a little obtuse, the syntax, but it works. Okay, spatial grid faceting. So this basically looks at the underlying grid. The grid is decided at index time. So it uses the very same grid that RPT uses for actually searching and filtering. But it just basically counts that, gives you the counts for that back from your search query. And so you probably are not going to display it like this, although you might, I don't know, if you want. You're more likely probably going to dither it, or you do clustering, you can do some other things. I have a demo on a web page, but I'll probably bring that up at the very end for time purposes, and you could fool around with it. That Steve McDonald has done, has a nice little sort of a exploratory web page where you can toy with them on real time and see what you like of the different ways of displaying them between this, and clustering. And then that's the link where that is. So several more on that. So how to, there's some tweaking you can do on the RPT field. If you know that you're going to do heat maps, you might not want the grid that's chosen to be what it will choose by default. Question?
Could you give an example of how you might use this in a search situation? Or is the heat map just for display, for looking at it? Or,
Yeah.
Or is it a mode of discovering stuff?
I think that's, so the question,
Discovery, right?
yeah,
We're using it as a discovery tool for thousands of layers, for example. We get heat map back of the overlapping, the distribution of overlapping bounding boxes. And because you know the count for every grid, you can have nice reactive behavior. So mouse over the map, you see how many are at any location. And then you can be getting a list back based on your zoom extent. Your zoom extent can be a boost in your search.
Gotcha.
Okay.
That's one scenario.
I think both of the possible things you said are actually the same. For display, yes, and for navigation, and for exploration, yes. The display is what's exploring you. It allows you to discover, oh, there's some stuff over there. Oh, there's a lot of stuff over here. Why is that?
Or there's nothing here at all.
And
Okay,
why is that?
waste time over there.
Mhm. Okay.
Right.
Thank you.
And so you might customize the RPT field because by default, you often don't mess with details like that. But if you're going to do heat maps, you might want to tweak it. That way the grids are more to your liking. Question?
On the flip side, is it possible to provide a grid and use that to constrain your search?
You can constrain. So for the purposes of constraining, in other words, you want to limit your search results based on those in a box. That's already done. That's not. You don't even need heat maps for that.
So not in a box. Like if you provide a grid, then the grid has values, right?
Okay.
So you would suppose it's a binary grid and it's zeros and ones. You'll search in areas where it's 1 and not search in areas where it's 0.
You
Maybe tweaking this too much, but
So there is this. I think maybe you mean this. So you can ask for heat maps. Facet is true. This is this type of faceting. You specify the field, and one of the things you will probably provide is where do you want the grid? Because it's probably going to be the search window of the map that you're displaying on the screen. Probably that, but it's not necessarily. You might want it to be a smaller part of the user screen that they've chosen, or maybe it doesn't even have to be a rectangle. It could be anything, and the counts will be limited to that area.
the reason I'm asking is that in the remote sensing field, a lot of times that people use a masking grid to limit their data search. So it's not one rectangular shape or not one polygon, but
That'd be 100 boxes. And you want
100
to
of
say,
different boxes.
throw 100 boxes at it. I want only those images that overlap these 100 boxes.
Yeah.
But I think you're asking from a search/filter, not from a counts. Like, is the ultimate point to get this, or is it just to filter?
Well, if you had that, you apply a binary, you not apply a binary 64 or 32 by 32 on top of that. And where there are ones, the reds come through.
Yeah.
Where there's zeros, they don't. Those are the ones that are valid in your search.
Interesting.
So a particular
So
argument,
Yeah,
let's say,
right now
of a
the
32
heat
by
map
32.
is a visualization of your query results.
Mhm.
What I'm saying is, on the other hand, if I give you a grid
Mhm.
and make that grid be my geographic filter to go in and do the search,
Mhm.
that may be a
So
stretch.
I think what you do is you would use that at index time. You'd pass every box as it's coming in against this arbitrary grid.
You would only use it at an index time if you knew a priori that you don't care about any documents at query time, no matter what the query is, if it's outside that,
Right.
which is probably not true. You probably want a query time. So what there's not is, I still think you're talking about a filter, and just a rather unique way of specifying the filter by instead of here's a polygon, here's a circle, here's a rectangle,
Yeah, yeah.
here's a grid,
Yeah.
and it could be very, And that would be a query shape, just a very kind of unique query shape. That sounds neat, but doesn't exist.
But it would be very doable.
Yeah.
With this
But-
platform.
It would be
Yeah.
easier just to apply a binary operation at the end once you get your results. Instead of worrying about all the indexing, take the results and just multiply by either a 1 or a 0 by each of your elements in your array. And only
I still don't think we're talking about the heat map, though. I think the grid inspired the notion of a grid filter.
Right.
Whether or not you want a heat map of it in the end is, if you do have a filter, if your filter was like some circle, and if you ask for a heat map of the world, your data will only show up in that circle. So likewise, if there was a way to specify some special binary grid as a means of filtering your data, then if you were to then want to do a heat map of the world, you would only see your data in that, whatever your filter was, whether it's something that's already supported or some fancy grid that is not yet supported. It would be pretty easy too.
But could it be discontinuous?
Yeah, sure. It does not need to be contiguous. That's one of the advantages, by the way, of so the spatial stuff in Lucene is going through a bit of is a bit tumultuous at the moment because it's not just one person, me, and now it's like other people with different ideas. So the spatial stuff that has existed to date has a very flexible separations of concern. So you can write a shape that is really a grid, and you don't need to write any custom fields, field types, or parser, or maybe a parser if there's no existing way to specify that shape. It's a new shape, I guess. So maybe you need to do that. But just those things you need to write, and you plug it in, and then you get everything else just kind of works because there's a framework around it with these different separate concepts. Let me back up. I got too far ahead. So new in Lucene Spatial. This is new in Lucene Spatial. That is, I mentioned some stuff that was new as well, but this is new in Lucene Spatial that is not in Solr. So this is stuff that you cannot yet do in Solr, but it's fairly low-hanging fruit in the sense that typically the hard work, so to speak, the real engineering is typically lower level, and Solr is often, in this case, exposing what's in Lucene. Sometimes it's easy, sometimes it's harder, but
Maybe it's exposing Elasticsearch and just be not importing it over.
I doubt this much. The Solr layer for this stuff tends to be so shallow that normally you wouldn't even look at whatever ES is doing because it wouldn't really apply. Like it might for something like a heat map, and it might be something more potentially more interesting, but not for just hey, there's a new way, a new field to search. We just need to search that. So new in Lucene Spatial, that which is not in Solr. So one is Geo3D, which I think is pretty darn cool. I've alluded to it previously with an existing question. This is a geometry library that is right now its own module within Lucene, even though in my opinion it doesn't belong here because it's worthy of being its own, having more visibility because it's so awesome rather than being sort of hidden within Lucene's bowels, except for me who give a talk. I'm like, hey, there's this really cool thing. You wouldn't necessarily know to expect this here. So it's written by Carl Wright of Nokia here in the Boston area, worked at Metacarta, and now he's doing this stuff for here.com or whatever it is, I forget. And it's a module of Lucene that is called Geo3D, but the actual Maven coordinates are like, they mentioned spatial 3D. And it's basically surface of a sphere and surface of ellipsoid of configurable axes. So you could use it for other planets if you were so inclined. And this is pretty cool because this stuff is hard. Again, aside from one library I know of called, I already forgot. It's old code at this point too on Google, whatever. Google's code spot. I forget what it's called, but it's, again, this stuff is this kind of math is hard to come by, and it takes expertise to be able to build this kind of library. This isn't a standard programming. This is like you need math skills, serious math skills, and he has them. And he's so we have surface. So we have points, LatLon rectangles, circles, polygons. Remember on the surface of a sphere or ellipsoid, and paths, buffered paths. Very cool. And interesting distance computations as well. So you could do the point to the edge of the shape and on the surface of a sphere as well. And there's multiple ways to do it faster and, again, driven trade-offs between actual spherical distance versus a faster and approximate and usually good enough way. Again, I don't need to remind this crowd, but I used this slide in another talk that, that the world is not actually flat, even though our web maps pretend that they are. You can't get to Miami to Anchorage with a straight line without going over the ocean. So the benefits of Geo3D, believe it or not, it was not written originally for the benefit of spherical accuracy. It was written for speed. Because once you get into this, internally it's called Geo3D, not because it represents everything in the 3D space. It does not. It only represents things on the surface of a sphere, and eventually it was adapted to ellipsoid as well, but we'll just say sphere. It was written for speed, because once you get your coordinates in geocentric x, y, z, once all your points and coordinates are in x, y, z, there's no more trigonometry. Everything becomes very simple, multiplies and adds. And that's can be really, really fast. It doesn't necessarily mean it's faster than the other spatials, because there's been some benchmarks and it's been eclipsed recently, but it's interesting to know that that was one of the reasons why. So it's not necessarily slow, depending on how you're using it. It's an alternative to JTS, again, but they're not the same. But if you want surface of a sphere, then this is it. If you want Euclidean 2D, then you want JTS, which is another library. And there is a Geo3D point field in Lucene to use it. And there was some limited integration with the RPT kind of stuff that I've mentioned in previous slides. Not quite into the solar layer quite yet, but there's an adapter that takes the Geo3D geometry, wraps it as a spatial for J shape, and then at that point you can treat it like any other shape. Okay, it's pretty close to having a solar adapter. There's not much needed. I'm trying to get a new a student that I've worked with before to contribute something. And then there's new, so separate from that, actually this is technically it's a part of that, but is new geospatial fields in Lucene. I just mentioned Geo3D point before. So right now we're just concerned about the use case of indexing points, and you want to efficiently filter and also sort. So these are 3 new fields, and there's another slide that I get into some more details. But naming is a challenge, by the way. We've had kind of fights about this, and what do you call these things when they all kind of they superficially do the same thing, but the technology is different, and so don't read too much in the name. You can use them all in the same way. You index points in latitude, longitude, and you provide a query shape, point radius, and or a LatLon box if that's what you want, and they will all work fine at that task for all of them. There's a semantic difference, obviously, whether it's Euclidean or surface of a sphere when it comes to polygons, but okay. Okay. And so there's some benchmarks, and I have another slide on that with a link to a page I might bring up or might not, depending on time. And basically with these 3 fields, LatLon point is the most efficient. It is much leaner, especially than so it's faster and leaner than the other guys. So I think it's kind of went out. These are kind of competing at the moment. There's benchmarks running all the time. I have a web page up where all 3 of them are plotted against various different metrics. And yeah, LatLon point at the moment is winning, but there's a lot of work going on right now and making them better. I want to get into some of the nitty-gritty details. Performance. I was mentioning performance. Yeah, depending on your needs, though, GeoPoint is good because if you only have to filter, then LatLon point is the way to go. But if you want to sort as well, then if you're trying to minimize disk of your indices, then GeoPoint kind of gets you both in one field for a leaner amount of stuff. And comparison to RPT, which is what Solr typically uses, RPT is huge by comparison in terms of the size of the index. And they're really, for a while I was looking for benchmarks, and they're hidden. There's not one comparing RPT with it. It's hidden in some JIRA issue somewhere, and I can't find it. But I remember the takeaway was that it's pretty fast compared to, say, GeoPoint, but its indices are huge. But it's not to say that our RPT is dead yet, because it supports things like indexing polygons and heat maps. And again, flexibility and custom shape. If you want some grid-based binary way of a filter, then there's an architecture to fit into without having to do lots of other stuff. There's more I could say in future. I whipped this up quickly. Things are moving quickly. A lot of activities going on in spatial nowadays, which is great because things are getting faster and more efficient. And there's more adapters needed on the solar side, which is at least the easy part, but nonetheless it has to happen. And somebody's time. I'm trying to encourage some open source contributors to do that. There's more, I think, ease of use and consistency that could be done on Solr side, because it is, I admit, it can be confusing to those that have anything beyond the very basic requirements. The basics are easy, but the moment you really want lots of various features, then you kind of have to know what's going on and the different syntaxes and when you can use them and stuff. So that can be improved. And of course, I should mention that heat maps are should be even faster this year, which are by many measures fast, but for really large scale, that could be faster. That is it for my talk. Is there any questions of what I've had to say? I've kind of answered a few out. Go.
Well, what are some cool applications you've been working on?
Well, we have Ben in the room for that. I'm working on, I was going to call it Hypermap, but now that's ambiguous. So I guess I call it the Billion Object Platform. I was going to ask you, we need a better name for this, maybe. Yeah, my code lately, I've been calling it the BOP. So, what I've been working on, a couple things. We're calling it the Billion Object Platform. It's for tweets or sensor data and other such things where you've got a large number of small documents and you want to not only have keyword search on them and faceting on time ranges and stuff, but you also want heat maps. And what I'm working on is kind of building the mechanics of that system and a web service for it. And on the lower levels of Lucene and Solr to make the heat maps even faster. Right now, I think they are pretty darn fast, but if you have, billions of points, the way it lays the data out is not in a way that's conducive to it being as fast as it could be. So I'm working on that kind of stuff. There's that, and I was going to mention some other stuff too.
As part of that, so right now all the heat map stuff is counts. So it's the values are counts, but David is coming up with ways of having numerics be the values coming from the documents that get aggregated by the grid cells. So then if you've got numerics, then you can handle sensor data, and your heat map is actually aggregates, say averages of say, air quality readings for all the sensors within a grid. You know what I'm saying?
Yeah.
So that's a new thing that Lucene hasn't done before.
Yeah,
right?
yeah.
Pretty cool. I think from a spatial perspective, in terms of opening up this big data mapping to more analytical use cases.
Yeah, I was asked that very question when I spoke about heat maps at Lucene Revolution. Someone asked about, hey, what about got some other numeric fields, and I want to show that. I'm trying to see if I have the certain demo up that I was going to potentially give. Do you want to ask the other question? What?
A very ignorant question.
Okay.
I've heard so many times saying that Lucene Solr being revolutionarily faster, right, in search than the traditional database. If you were to explain this to someone like me who know nothing about the technology,
Oh, cool.
What made it so fast?
Great question. Yeah, I remember when I first encountered Lucene, and this was back in like 2002, maybe. Lucene's an old project. I started in 2000, or maybe technically 99, by Doug Cutting, who, by the way, did Hadoop, MapReduce, and he's like a tech god, honestly. And it was at a conference, and I saw him, and everybody's like shaking his hand, taking his picture. And I asked him for advice and all kinds of stuff. Anyway, so I remember when I first used it, and I was like, wow, that was fast. Like, what did it just do? How did it just? And then, because I never really thought about this stuff at all. Like, I never took any university courses on it, so I never took any of the, although I've used databases, I had never taken the database classes. I just sort of learned things as I needed to. So once I figured out what it was doing, I was like, oh, it's cheating. So in advance, at the time that you index data, it's like a book. If I know in advance that I'm going to need to go to some word and know which pages have that word, I'm going to build an index in advance so that up front I go through all the words and I build an index, just like the back of a book, although more detailed because it has more information than a typical index, but it can be slimmed down to be that minimal for some cases. So the secret, if you will, is an inverted index of so-called terms in Lucene's terminology to matching documents. And it's very flexible in that if that's your pure requirement, I'm going to go from a word to matching documents, it can do that. But typically you also want to do, say, phrase queries. So it's not enough to just know that it's on this document, but then you want to know which word position on that document. So that way you can intersect it with another word to make sure that they come up adjacent, as an example. And then you can even add other metadata as well. Some people have specialized needs. And so it's very fast at doing that. And it has all sorts of fancy ways of holding large sets of document IDs in memory with bit sets and intersecting them together, which is wicked fast to be able to kind of quickly kind of go through them and to do Boolean disjunctions, conjunctions, which is ors and ands, and by leapfrogging through, you do a query that has, you say you want this word and that word, but not that word. It's able to kind of navigate these so-called postings lists. The postings lists say that this word is in these documents. So there's very efficiently ways of navigating through these indices. So the secret is an index, and that takes space. You commonly put your text data or whatever it is into Lucene, and in addition, it's got to build its indices. Those are commonly like maybe 25% of the original data as well. But there's lots of compression at play, so your original data in Lucene is often a quarter of what it might be of the original. So it's very good at that.
So another trick would be when you have live streaming data coming into your database, you would be constantly building indexes for the new entries.
Yes.
And updating your index database.
Yes. So that's exactly right. When you add, I could have a whole talk about how Lucene works under the covers, but yes, as you add new data on the fly, it's adding to an in-memory index of a buffer of documents. It's keeping track of up to date. So it goes through all the text, finds up all the words, increments counters on all those words to say it's in this document, this document, this document, this document at these word positions. And then once that buffer gets full, it flushes it to disk. The one challenge with inverted indices is that they don't update. You can't, and thus, in Lucene and thus Solr, because Solr is based on Lucene, you can't truly update a document. You're never updating it. You're marking the previous one, you're flagging it, if you will, as marking it as deleted and adding a new one all over again, which can be slow. And so so for those that need to rapidly, so one anti-pattern for Solr, it's good to kind of discuss these things. These things aren't for everything. Solr is not the one, it will not solve all your problems and do your dishes. It will, in particular, what some people naively want to do is add a document to Solr and then have a counter. And every single time someone clicks a search result, say, maybe on their search result screen, maybe you want to increment a counter because maybe you want to use that to influence relevancy. Say, oh, lots of people are clicking on this. It must be very relevant. A lot of people want to do that. But if you naively tell Solr to increment that number, it needs to read up the entire stored document, add a number, and add it back as an entire new document. So, but if you're doing this at scale, you're hitting a wall. So there's workarounds to these kinds of things, but that's a fundamental limitation in Lucene. And we're trying to, for certain use cases, we're trying to do it in a way that, for some use cases, we're trying to find ways to kind of do it, but that's I'd say the weak point of a Lucene-based index. No updating. Yeah.
Am I allowed to follow up another?
Go for it.
So if there's no updating, then the live streaming case, if we have a fixed a billion object in the live database for search, right?
Mm-hmm.
And they keep streaming in, and then you have to keep dropping the old ones out,
yep.
Right? Then that index updating, well, no updating, whatever, how you handle that would be a huge overhead.
There's overhead. So when the way this works, I already mentioned filling up buffer in memory of documents that are in flight, that have not yet been committed. So once you flush that, and Lucene will automatically flush it. And then at a certain point when you say commit, it flushes whatever's there. And it kind of marks the existing so-called segments as like a commit point. Now, if you keep doing this, you're going to get lots of segments, lots and lots of segments, and it'll grow to a point, you know. So internally, what Lucene does is that it sees, once it sees by default 10 segments, then it merges them together into one. And so it actually has, it's done in a tiered sense. So it has it forms a logarithmic, I'd say, size. If you were to visualize, in fact, Mike McCandless, Lucene committer, has a visualization on YouTube somewhere of, it's very popular, and those in the search community, that displays what it looks like live. And you see large indices, and then you see it drop down to the smaller ones. And then it's constantly, you know, merging up to be bigger and bigger segments. And as it merges, documents that are deleted obviously get effectively ignored during the merging process. So it can, but that can be very tumultuous. Like indexing is not, you know, indexing uses I/O and uses CPU, has to do some real work. It has to merge those indices together, which is not, you know, it is a hotspot. Yeah. Cool. Okay. Thanks for letting me speak to you guys. It was fun.
Excellent. Thank you.
I'll stay around here longer if anybody wants to chat.
Let's go and stop that broadcast.